Okay, so welcome everybody. Good afternoon. As a reminder, we will not have class on Monday. So you're still welcome to come in and sit in here between 12 and 12:50, but I won't be here. Probably your classmates won't be here. It'd be a lonely afternoon. No class on Monday. Homework number 1 is available now. Has anybody already looked on MU Online to make sure that it's there? Gotten an early start? Few people. All right, I see some heads nodding. So homework 1's available now. It's due a week from today. Remember that the assignment needs to be uploaded before class. And what's my late work policy? No late work. That's my policy. And of course, I drop your 2 lowest homework assignments, so it's not like I'm that heartless. But we've got a big class. I want our grader to start scoring your homework as quickly as possible once it's submitted. So everything's a lot easier if we say no late work. So it's due before class on Friday the 24th. And what you should do is you should create the PDF file of your solution. I think that this homework, you're doing all the calculations by hand. We're not yet at the point where you're going to be using Excel. So you'll have multiple pages of hand calculations, and you just turn it all into a single PDF. Not one PDF file per page, just all together. When you use Cam Scanner, you can create a single PDF file with all of the pages. And does anybody else remember my one other request when it comes to PDF files and the formatting?
Black and white.
Black and white. And the reason for that is that it's a lot more sharp and clear, and the image quality is better, and the grader will be able to view what you did with more precision. Any questions on the announcements? Yeah.
For the homework, does it matter what kind of paper we use? Like, do you prefer like notebook paper?
Good question. That's really a good question. Because we're going to be drawing cash flow diagrams this semester, and we're talking about cash flows today, ironically, my suggestion is that you indulge and splurge and buy the engineering notebook paper. Have you seen that expensive, it's kind of like greenish yellow notebook paper where they have the graph on the back side of it and the front side of it's blank? That's the stuff. Hold it up. That's the stuff. It's way overpriced. I don't know why a pad of paper costs, what, $9 or something?
I think it's like
$7?
Yeah.
You found a discount supplier, I guess. It's not cheap is the point, but it's important because it's going to allow you to be a lot more organized in drawing these cash flow sketches. So my preference is you use that. Unlined paper would be okay. The worst is like lined notebook paper, that just doesn't look good when you're drawing the cash flow diagram. So my preference is you avoid that. Are there other questions related to the announcements or anything else? Yeah.
Do you want a cover sheet for the homework?
Good question. No, I don't need a cover sheet. Since it's uploaded through MU Online, like the identity of the student and the section and who it's being submitted to, all that's kind of built into the way that you're submitting it. So a cover sheet's not necessary. Another question in the back? No, you're just scratching your head? Yeah, I knew that. All right. Don't scratch when I'm looking at you or I'll ask you a question. Just kidding. Any other questions? Be sure and try this on the way out if you didn't try one on the way in. They're really tasty. This student of mine, she is originally from Iran, and I taught her when I was living in Dubai, and she moved to the United States. So she's had a real international life, but she found a bakery in California that makes Persian sweets, and she sends me a box of these Persian sweets every Christmas, and I'm just worried that my teeth and my blood sugar can't handle it if I eat it all myself. So you're helping me out. You're doing me a favor. All right, so we're going to talk about cash flows today. As a reminder, everything that goes on in class is recorded and loaded into YouTube. So if I move through something too quickly, of course, you can always revisit the lecture on YouTube after class. And the textbook is a really important resource as well. I saw some of you are getting your books in, and I encourage you to review the corresponding material after each class meeting. All right, so cash flow diagrams are used to simplify what otherwise might be really wordy. For instance, look at this problem statement in italics. You borrow $10,000 at 6% compounded annually to be paid back after 5 years. How much must be repaid? I mean, that one's not as complicated as they sometimes can get. But what's even simpler than that would be to create a line, a horizontal line that represents the passage of time. So each one of these tick marks is a year. And what we did is we said anything that's above the line, we're going to call an inflow, and that represents the money that you get. It's coming to you. And anything that's below the line would represent the payments that you make. So it's outflow. So we've got inflows and outflows. And the reason why we follow this system is that then we can represent problems in a graphical fashion. And this is way easier to digest than a written problem statement. It doesn't leave anything to the imagination. It's just the dashed line and the question marks make it clear that what you're trying to find is some future amount. This solid line, and of course it's saying the given amount of 10,000 is at times 0, meaning now or the present. So if you get 10,000 now, how much do you have to pay after 5 years if the interest is 6%? So cash flow diagrams are just a convenient way to express problems in a graphical fashion. And it doesn't matter if the language that the problem statement was English or Chinese or whatever, this is universal. So it's very clear, and we can be systematic in solving for F. So does this make sense, the value of doing something like this? You get a feel that, yeah, that is pretty simple when you look at it. At the end of the semester, I could show you a picture like this with nothing else, and you'll know exactly how to solve for F in less than 30 seconds. I mean, that's how instinctive it'll become, is you'll just look at these cash flow diagrams and be able to solve them very quickly. And these are the kinds of problems that show up a lot on engineering licensing exams, because they're really well suited to that computer-based format when you've only got about 2 minutes on average to solve each question. You can knock these out really easily if you know how to do them. So that's what we're talking about today, is cash flow diagrams. Now, a couple of important terms. The inflows represent money that you get. So the different types of money that you get, that could be revenue if you're selling items. If you're from the perspective of the accounting department, it could be receipts on sales, income meaning salary. Now this next one is a little bit more abstract, but savings generated by projects and activities that flow in. So what that means by savings is it means if you used to spend, just as an example, if you used to spend $100 a month on electricity, but then there's something that happens, maybe you put in a solar panel. And so now instead of $100 a month, you're only paying $50 per month. You'd consider that difference as an inflow. So it's what you used to spend and you don't have to pay as much anymore. And so the savings, the difference between what you used to spend and what you're spending now, counts as an inflow. So it's positive. Cash inflows are positive when we plug these amounts into formulas. Outflows, by contrast, are negative, and so we use a minus sign when we put the amounts into formulas. And so just different words for outflows would be disbursements. So if you're in the accounting department and you're paying your supplier, that would be an outflow that's down on the cash flow diagram. Costs, expenses, taxes, and activities that flow out. Now this word savings, that can be a tricky one. So let me ask you this. If you are putting money into a savings account, are you getting money or are you losing money? Temporarily at least. You know, like from the perspective of your wallet, if you're putting it into a savings account, is that an inflow or an outflow? It's an outflow. But wait, the word savings is an inflow. Well, savings account isn't the same thing as reduced costs. So by savings, what that doesn't mean a savings account. That means that you're not spending as much as you used to on an expense. But if you're investing in a savings account, at first the arrows would go down while you're making the deposits, and then someday in the future when you withdraw the money, the arrow would be up, because then that would be an inflow. You're getting it back eventually. I just wanted to clarify this word savings and what it meant. By the way, I rearranged the order of some of the slides that I'm showing you today compared to what's in the printed lecture notes, and so don't be thrown off if you don't see a slide right away that is there in print. I'm always tweaking things a little bit, and so I rearranged some of today's slides. So net cash flow means the difference between inflows and outflows, or in other words, revenues minus disbursements. So in 1 year, you might have both income and expenses, and so the net cash flow is the difference between the two. And if you have a positive net cash flow, that's profit. If you have a negative net cash flow, then that means, have you ever heard the phrase, you're in the red? If you're in the red, that means your company is losing money, or maybe you personally are losing money. And some companies like Uber may be in the red for a decade or more before they are ever profitable. For a long, long time, Amazon lost money every single year. They're profitable now, but that's a relatively recent development. That's within the last, I don't know, maybe 5 or 6 years that they finally became profitable. But for a long time, their inflows were less than their outflows. Okay, this last bullet point, the end of period assumption, I'm going to illustrate on the next slide. But what it means is that if you are operating a company and you're getting revenue, let's say you're operating a consulting company and your clients pay you all through the month. What we do is, to simplify things, we aggregate all of the revenue you receive during a period, and we assume that it comes all at once at the end of the period. Now, if we need more resolution, we can make a cash flow diagram that's days. 0, 1, 2. That could be days. It could be weeks. It could be months. Most commonly, we'll make it years. But it could be any time period. But the end of period assumption is just that when revenue or disbursements occur, it happens at the end of the period rather than in the middle or at the beginning. Okay, so here's how we draw a cash flow diagram. First of all, there's that horizontal axis that represents time, and the time can be any units of time you like. And it should be roughly evenly spaced. I mean, I'm not going to get a ruler out and make sure that there's exactly 10 millimeters between 0 and 1 and 1 and 2, but it helps things to be organized and neat if you make it about evenly spaced. And that's, another argument in favor of that engineering computation paper, is it makes it easy to draw a good cash flow diagram. The end of period assumption means that any money you get starting now and until the end of the first year is going to be at 1. Now, this distance between 0 and 1, the first year is between 0 and 1. This is the first year. The beginning of the first year is times 0, meaning the present. The end of the first year is at 1. So the time between 1 and 2 is the second year. And the end of the second year is here at 2. The beginning of the second year is here at 1. So sometimes in a word problem, it'll be saying that revenue was received during the third year. Well, that would mean that you have to put the amount at 3 using the end of period assumption. So the first part is the horizontal line. The next part is the arrows. And roughly speaking, the length of the arrow should be scaled to identify the magnitude of the amount, approximately. And so if this is $80 of outflow, then this is roughly, I don't know, it looks like maybe $50 of inflow. I mean, if this line length is 80, that's not as long. It looks maybe a little longer than half. So the point is that the length of the arrow gives you an idea of the relative amounts. It's customary to also write the amount above the arrow itself. So you'll see that I follow that convention when I give you problems. Any questions so far about cash flow diagrams? Okay. So here's a problem statement. You borrow $10,000 at 6% compounded annually to be paid back after 5 years. How much must be repaid? The other thing about these cash flow diagrams is that we sometimes put the symbols right on the cash flow diagram itself. The first one I showed you, for example, we had P equals 10,000. And so this would be the same thing. P, the amount of money at the present, is $10,000. You borrow that money, that's the triggering event. And we call it 0. I mean, that doesn't mean like 0 AD. That just means like the start of the scenario that's posed, like right now. 0 means now. And so P equals 10,000, and we would put that arrow as an upward arrow because you're getting the money. From your perspective, when you borrow money from the bank, they're giving it, but you're receiving it. And here it says you. So that means if we do a cash flow diagram, it's going to be from your perspective. N equals 6 because that's the number of periods, and it says that the interest is compounded annually, and it says it's going to be after 5 years. And so the clue here is that the units would be each one of those tick marks on the cash flow diagram should be representing 1 year period. And then the unknown is F, the future amount. How much must be repaid? Well, it doesn't say how much must be repaid in the future. Well, it's implied. And there's going to be more and more things that are implied. Like the first assignment I give you, I try and make it as clear as possible. The next assignment, there's a little bit more ambiguity if you don't know how to read problem statements, but there's always kind of like a default assumption that's most reasonable. So here, for instance, it doesn't say how much must be repaid after 5 years, but it said that earlier, right? It said to be paid back after 5 years. So, I mean, if you want to be obstinate and willfully confused, there's always a way you can misinterpret a problem statement. But my point is that there's always the most reasonable assumption as well. And so sometimes you just have to like relax and just say, well, I guess they mean how much must be repaid after 5 years, and just go from there. And of course, I'm always willing to, if you want to stop by during my office hours, I'm always willing to verify, yeah, you understood that problem correctly. If you've got a question about it and you're not exactly sure what they mean in a problem statement, we can work on it together. But you'll get more comfortable with the way that these word problems are phrased, and this is how we would break down the problem statement into its corresponding variables and symbols. I, we could represent I as either 0.06 if it's expressed as a decimal, or 6% as a fraction. In formulas, you'd need to express it as a decimal. All of the formulas I'm going to give you this semester, if you put the I in as a percentage, then it would give you a really wrong answer. Like if you put the just 6 instead of 0.06 into the equation, then it would say you need to pay back like $100 million. You'd think, well, that seems a little high for 6% interest per year. And the point is kind of like do a reasonableness check. Like if you accidentally substitute in 6 instead of 0.06 and suddenly it says that the amount to be repaid is this astronomical sum, then that's a clue that maybe, oh yeah, I is supposed to be 0.06, not 6. Okay. In the book, there's a section that describes uncertainty. And just because we can't do everything at once in this class, I'll teach you one concept and then another one, I'm usually going to assume that we can predict the amounts in the future with perfect exactness. And so what this is saying, for instance, is you receive exactly $150,000 every year for 6 years. Well, sometimes you're not able to project into the future with that much precision. Sometimes you just have to use an estimate. And so if you wanted to represent that uncertainty, and instead of giving an exact amount, show a range, then the way that you would express that range is you could say, every year for the next 6 years, I'm going to receive between $135,000 and $150,000. And so instead of a line that has a fixed length, these dashed lines kind of illustrate the range of uncertainty. We won't have a lot of problems that use this uncertainty principle, but we'll have a few, and so I wanted to show it to you. All right, I have an in-class exercise for you today. Hopefully you've got a good place to put it. You know, that the 3-ring binder that I suggested, by the end of the semester will be nice and full. So it's going to be a good investment. You won't have enough space if it's just like a lined notebook that has a pouch in the front. Probably there won't be enough space in that. No. So we're just solving problems 1 and 2 on this one, and then we'll talk about the back side of the paper after we've had a chance to review and make sure that you did the sketches correctly. Let me put the answer to the first one on the screen just to see if we're all headed in the same direction. Okay, so the first question, draw a sketch including labels, it says. And so the labels are like P if it's a present value, F if it's a future value, A means if it's the same amount over and over. That's called an annual uniform series. So it looks like this one we've got, I didn't draw it to scale very good, did I? If this is 3,300, that line should be way longer. So -1 for Dr. Wade on that. But at least the direction is right. You receive it, and so it's an arrow up because you got 10,000. And then starting 1 year from today, you have outflows, 4 outflows. So 1, 2, 3, 4, and they all have the same amount, so the arrow lengths are equal. That's number 1. Okay, let's look at the second problem. There's 2 different perspectives on the second problem. It says to do it from the bank's perspective, and then also you do it, did I also say, and from your perspective? Okay, so the first one, if it's your perspective, then you save $10,000. That means you're putting it somewhere else. It's coming out of your pocket and going into some other location. So you save it and then you withdraw it. Wait, how did we know it wasn't talking about those used to be expenses? You know, because if it was the kind of savings that, you know, you used to spend a certain amount and now you don't have to pay as much, so that's how much you're saving. What was the clue that it's not that kind of savings?
You withdraw the balance.
Yeah, it's the fact that the balance is withdrawn. So that makes it clear that, you know, the savings it's talking about is a temporary outflow to another account that eventually is going to be recouped with interest. All right, so the arrow is down. When it's your perspective, you'll notice I use the label A equals 10,000, and then F, the amount that you're getting, is an arrow up. It's dashed. We don't know how long it is. This problem statement never said anything about interest. If it did say an interest rate, then what you'd do is you'd say, like, maybe if it was 5%, you'd say I equals 5% in the vicinity of the diagram, just so it's handy. But it didn't tell us the interest rate, and that's why we don't know exactly how big F should be. All right, so that's your perspective. Now, how does the bank see things? From the bank's point of view, what's going on is that they receive $10,000 at the end of each year for 6 years. And then they have to be ready to have a big outflow because that's when you get it. So from their perspective, there's a lump sum amount coming out in year 7, and that's an F. An F means a single future amount. Any questions about sketching cash flow diagrams? So let's just look at the two different perspectives. They're kind of like the mirror image, one versus the other. Your perspective versus the bank's perspective. All right, on the back side of the paper is where we talk about cash flow tables. Now remember, the net cash flow is the difference between the inflow and the outflow. So inflow amount is a positive. Outflow amount, there's two different ways we can handle it. One is that you can put like a negative anytime you see an outflow, or if you just remember that outflows are by definition negatives, then you don't necessarily have to put excuse me, that minus sign for each of the amounts. And so in year 3, there's going to be both an inflow and an outflow. So end of year 3, you're going to have a net cash flow that takes the difference between those two into account. So fill in this table, translating a cash flow diagram into a cash flow table. And cash flow tables are important because we'll often use Microsoft Excel in our calculations.
Dr. White?
Yep. Yeah. So the other way, I guess, it could be interpreted is that over the course of 3 years. But the problem with that is that it's not spelling out like what the schedule is, you know, when during each of those years a certain amount is coming. So then the more direct interpretation would be that it's a lump sum all at once. But that's a good example of where, in theory, it could go either direction. Okay, I've got the cash flow table on the screen there. That chicken scratch is really not my finest hour. So net cash flow is the inflow minus the outflow. So for instance, at the end of year 3, the net difference between the revenue we receive and the expenses we pay out, the net difference is 500. So there's two different annual series. There's the annual series that goes years 1 through 5. And then there's a different annual series, years 6, 7, and 8. So that's like A1 is 2,000, A2 is 3,000. So that means during each of those years, the amount is the same. And then there are these individual single future amounts that are costs. It could be maybe like a calibration is having to be done for some equipment, or maybe periodic maintenance and upkeep. Whatever it is it reduces our net cash flow for that year. All right, now these last two problems here. Create a cash flow diagram from the bank's perspective for this fourth one, and then I just want to see, we haven't talked a lot about compounding yet, but I want to see if you can translate this cash flow diagram and use this formula to calculate what is the amount in year 5 that has to be paid. That's kind of like a stretch problem, you know. Let's see if you can make the leap before we specifically talk about it in class. All right, here's the answer to number 4. A present amount of 25,000 and a future amount of 30,000. Now, a couple of people have noticed that it didn't exactly tell you that it was you paying the bank in a lump sum. Like the word, it just says that you will pay the bank 30,000. It didn't say, you know, maybe it's 10,000 each year versus all at once. Well, if it was going to be 10,000 each year, then they would have said a single amount each year for 3 years. And so the more, I guess, because it wasn't said explicitly how much each came in different years, it's implied that it is all at once. And now on this last one, what we've got is a cash flow diagram where there's single amounts, a single value that's P, you know, times 0. Then that means that the P is 10,000, I is 0.06, and N for this 10,000 amount, to get it over to year 5, is going to be 1, 2, 3, 4, 5 years. Now we can't just combine the 10,000 and the 5,000 together because they're in different years. So you can't just add it directly if the amounts are in different years. The only way to combine them is to put them into the same year first. And so the way that you do that is with this formula. So the $5,000 amount, to get it to year 5, that's only 1, 2, 3, 4 as the N. So the solution would say it's going to be the combination of the 10,000 compounded for 5 years and the 5,000 compounded for 4 years. So then the combined amount should be 19,694 and 64 cents.
So
Yeah.
actually how banks still track when you deposit stuff?
That's right.
Wow.
Yep. The last thing I'll mention is that when you do calculations like this on your calculator, don't round off in the middle of all of your work. You know, when you do 1.06 to the 5th power, what do you get? Let's just do that real quick. I'm turning on my calculator here. 1.06 to the 5th power is 1.33822557776 and so on. If I just said 1.3, like if I rounded it to 1.3, then it's not going to be accurate to the nearest penny. If I want it to be accurate to the nearest penny, then this factor has to have 1, 2, 3, 4, 5, 6, 7 digits. in the factor. So the point is don't round off until the very end when you're expressing the final amount. Okay, as a reminder, no class Monday. I will see you on Wednesday, and then next Friday is when homework number 1 is due. So I hope you have a good weekend. I'll see you in class on Wednesday.